Okay, so basically last week I had left a few quadratics for you guys to try and sketch. So let's see how we would go about this one, for example. So I've got x plus 5 square. This is into its completed, what we call completing the square form, because that gives us some help when it comes to sketching. So the first thing we would try and find here is what we call the y-intercept. Okay, so the y-intercept is where the graph crosses the y-axis, where it is the the graph intercepting the y-axis. So that happens when x equals 0. So if I was to replace x here with 0, you get 0 plus 5, 5 square. 5 square is 25. Then 25 take away 5 would just be 20. So that's why your first point here would be 0 and 20. Okay, so once we've got the y-intercept, the next thing we would do, hold on.
Hi Adrian, how you doing?
Okay, how are we doing? We're just going through some of the homework.
Sorry, I'm late. I was tidying up my UCAS. I was getting ready for submitting it.
No worries. So the completing the square form gives us where the minimum turning point, in this case minimum, because we've got the factor of x square, which is positive. So I've got a minimum turning point at x equal when this x plus 5 is 0, so x equal -5. And that means y, when this portion is 0, is equal to -5. So you would just write the minimum turning point happen at -5 for x and -5 for y. So if you were to place that point, it would be -5 on x. So in this x-axis, what I've done is, because I've got it labeled from 0 to 10, it's divided by 2. So that means here you see this is 20, 18, 16, etc. So that's why I just said divide by 2 here, because I needed 20. So -5 would be where -2.5 is. So you put that second point, and then you just draw your graph based on those 2 points here. So this exercise this is how you would deal with it. Basically, you would find the y-intercept and do your turning point. And we had done some other cases. So for g of x, in this case here, we would have a y-intercept 0 for x, -5 square, which is 25. 25 plus 5 would give us 30. And the turning point, again, minimum turning point, which would mean x equal 5. And when x equal 5, y equal 5. So the turning point here would be 5, 5. So you would put those two here. So 5 on x. And remember, that should have been 5 here. Positive 5. Okay. I'll fix that. I just noticed. Yeah, so the 5, 5 should have been here. And then the graph itself would come higher than that. So the graph, if I was to fix this, the graph would just move up. Right up to there. Okay. So I need to fix that. So now for h of x, 10 plus x minus 3 square, you would do the same thing, y-intercept when x equals 0. -3 square would be 9. 9 plus 10, 19. So y is 19. And the minimum turning point when x equals 3, y equal 10, and your turning point would be 3, 10. So 3 here, and again, I'm using here a scale divided by 2. So at 5, it's normally 10, and you would just draw your graph. Just a quick sketch, basically, based on 2 points. Okay. So the real homework which was left was here. So you were asked to calculate, first of all, the discriminant, b squared minus 4ac. And based on the value of your discriminant, you would be able to say if it meets the x-axis at 2 distinct points. And that was the case if you calculate b squared minus 4ac. So to calculate b squared minus 4ac, obviously you identify a first, then b, then c. So b is -4, so b is the coefficient of x. A would be your coefficient of x squared. And c is normally the coefficient of x to the power 0, but x to the power 0, we've seen that before, it's just 1, so that's why it's 3 times 1 here. So -4 squared minus 4 times 1 times 3 is just 16 minus 12, which is 4. So based on that, we know that the discriminant is positive. We've just verified that the graph meets the x-axis at 2 distinct points. For b, I would do the same. B squared minus 4ac, we got 64, positive again. For c, so this time I've got 0 when it comes to, so you've got a equal 1, yeah, c equals 0, so that's why that second part is 0. But -2 squared, remember when you write it down, you need to put the 2 brackets, because if you don't put the 2 brackets, it's just going to be 2 square, or -2 then square. Okay. For D, we've done that one. We noticed that it was 100. When we calculated it, you do the same for E, 121. And for F, this is just practice. So you just put that as positive. And the last one, 16, which is positive. Now, once you've got your discriminant, they've asked us to find the roots and the y-intercept. Okay, so on the next page, I've got A, which was x squared minus 4x plus 3. So you need to factorize x squared minus 4x plus 3 to get your roots. Just like we did when we were factorizing a quadratic, you use MAM. You're looking for 2 numbers. If you time them, you get positive 3, but when you add those 2 numbers, you get -4. So the 2 numbers I've got are -3 and -1, which would meet that. So now that means my roots are just this equation equals 0, and it's 0 when x minus 3 equals 0, or x minus 1 equals 0. And that happened when x equals 3 and when x equals 1. So the roots 1, 0, 3, 0. The y-intercept, just like we did earlier on, it's when x equals 0. So x equals 0, 3. And the turning point, this time, to find my turning point, because I don't have the quadratic in the form here, in completed square. So what you do is you use your roots, you add both roots, 1 and 3 in our case, and you divide them by 2. So 3 and 1 divided by 2 gives me 2, because it's basically x equal 2 would be my axis of symmetry. So, and when x equal 2, you substitute x equal 2, you can do it here, where y is in this factorized form. You can do it as well in the original one. So it's easier to do 2 subtract 3 times 2 minus 1, or 2 subtract 1. So that's -1 times +1, which is -1. So I've got now my turning point, x equal 2, y equal -1. And it's important as well to state, when you're asked to give the coordinates of your roots of the turning points of the intercept, get into the habit of writing them as an X and Y coordinates. Then you put all your points. So I've got the roots, I've got the Y-intercept, I've got the turning points, and now you just join them, trying to be as symmetrical as you can because it's just a parabola. Okay. So yeah, I didn't need the Y divided by 2 here, so I'm using the proper scale here. So for the next one, I'm going to factorize x squared plus 4x negative minus 12. So that's x plus 6 times x minus 2. My roots are going to be 2, 0, and negative 6, 0. The intercept when x equals 0 is going to be negative 12. The turning point, I'm going to add here the roots. Oops. I'm going to add the roots. 2 and negative 6 divided by 2 equal negative 2. And once you've got x equal negative 2, substitute in the function there. Negative 2 plus 6 is positive 4. Times a negative 4, which gives me negative 16. So in this case, I'm going to use a scale where I'm going to divide the numbers that you see there by 2. So turning point, negative 2. So roots 2, 0, negative 6, 0. Then I've got intercept at 0, negative 12. So remember, this is y divided by 2. So that's why I've put it at 0, negative 6. And negative 2, negative 16, shown here at negative 8. But if you were to do it properly, you would change the scale for your y-axis and put the correct numbers there. Okay, it's just a change of scale, but because I'm using the same template here, I just decided to divide by 2. But that is not the correct way of representing it if you were to do it on a proper paper. Okay, then you just draw your parabola through your points as best as you can. So that's A, B. So now for C is even easier because you can factorize here x times x minus 2, x squared minus 2x. So I've got 0, 0 for my roots because when x equals 0, and 2, 0. Intercept is going to be where we cut, let's say where x equals 0, y equals 0. Turning point 2 plus 0 divided by 2 is just 1. And when x equals 1, you can do 1 squared minus 2 is just negative 1. So put your points and try and draw this. So if you think it's going to be a bit hard to draw, you can just add another point. You can decide, okay, if I try 4, I get 4 times 4, which is 16, minus 8, so it's 8. So normally we should go through 4 and 8. So you can see there, if you needed another point, you would go through 4 and 8. Okay. So we've done this one. E factorized, roots negative 6, 0, 5, oh sorry, yeah, 5, 0. Y-intercept when x equals 0, y equal negative 30. Minimum turning point, x1 plus x2 divided by 2, that's negative a half. And when you've got x equal negative a half, this is where you need to work with your fractions. You can replace negative a half here, plus x, minus a half, minus 5, and you end up with negative 30 quarter, 30 and a quarter. Okay, and that's why you can figure that out. It's close to 30. So my roots are at 5, 0, negative 6, 0. minimum turning point. Yeah, so it's well below. Okay, and the intercept, same thing. So I don't have the correct scale here. So I've tried to change it by going -5, -10, -15, -25. So for the last one, f, x squared minus 2x minus 3 factorized gives me the roots, intercept when x equals 0, y equal -3, turning point x1 plus x2 divided by 2, and when x equal 1, 1 minus 3 is -2, times 2, -4. So I've got my 4 points. You just plot them, plot the y-intercept, and put 1, -4 as your last point there, and you just draw your graph. Okay, so that was how you would sketch if you're given a quadratic. How would you sketch, for example, finding your roots, finding your intercept, finding your turning points? Okay. So the next question we had was how many points of contact do graphs of the following quadratic have with the x-axis? So if you get a question like this, basically it's the discriminant that tells me how many points of contact. What is the value of b squared minus 4ac? Because if you look at your quadratic formula, you'll see you've got minus b plus and minus square root of the discriminant divided by 2a. That means if I calculate b squared minus 4ac and I get a positive value, then I know I've got 2 points of contact because it's positive. For the second one, I've got a half square, b square is a half square, minus 4 times 1 times a quarter. So 4 divided by 4 is 1, so that becomes minus 1. So a quarter minus 1 is just minus, it's negative, yeah? If you've got a number less than 1 to take away from -1, you get a negative value, then you just go no points of contact. Or sometimes if they ask you for the nature of your roots, you said no real roots. Okay, so here we'd get 2 real roots. Okay. So next, I've got C. For C here, I've got B equals 0, A equal 2, and C equal -9. And that's why you put 0 square. But you've got a negative times a negative, give me a positive. Then I know here I've got a positive discriminant. And if you've got positive discriminant, you get 2 points of contact. For E, you need to be careful here. Remember, A is the coefficient, the factor of x squared, so that's -1. B is 3 and C is 0. So if you do that, you get 3 squared minus 0, which is 9, so 2 points of contact. And for the last one here, F, you get again a positive value, which tells us we've got 2 points of contact. So this is us calculating every single discriminant. Okay. In this question here, we were asked to first rearrange each quadratic. So obviously what I'm trying to find is to rearrange them so that they come up in the form of ax squared plus bx plus c. Then determine the nature of the roots, obviously by calculating once again the discriminant b squared minus 4ac. So for the first one, you expand. So x times x as x squared plus 3x. And what we're going to do is, because we want everything to be on the left side, take away 2x on the right. That means you need to take away 2x on the left as well. Add 3 because I've got to take away 3. for both sides. That side will become 0, and you end up with x squared plus 3x minus 2x plus 3. Then we need to simplify, or what we call tidying up, grouping the likes. So 3x minus 2x is 1x, or you just write it as x. And now I'm going to calculate my quadratic, because I've got it into the standard form, ax squared plus bx plus c. And when I calculate the quadratic, I notice that I get a negative value. So the nature of the roots, you would just write, because my discriminant is negative, I've got no real roots. That was it. That's how you would answer this question. So that would give you a couple of marks to expand and simplify, a mark to calculate your discriminant, and a mark to make a statement based on the discriminant. So that could be worth 4 marks. For B, we'll do the same thing. I've got x minus 2 squared. So you expand that. That gives you x minus 2. So you would just go expand it like this. Just come and say x minus 2 times x minus 2, if you prefer it, minus 3. And we've seen that before, where you just do x times x, that's x squared, minus 2x. So x squared minus 2x, and then minus 2x again, that becomes minus 4x. And then you've got negative 2 times negative 2, that's plus 4 minus 3 is just plus 1. Which is what we've done there. So x squared minus 4x plus 1 equals 0. Discriminant b squared minus 4 AC, so I've got 16 minus 4, which is 12, positive, so I've got 2 real distinct roots. Okay, so if I had 0, it'd be 2 real and equal roots, but because I've got 12, it's distinct, because remember, if you do plus and minus root 12, you will get 2 different values. So C, we've done that one. For D, again, expand 2x minus 1 square, negative 3 times x, negative 3. And then you end up with 4x squared minus 7x minus 2, discriminant positive. So I've got 2 real and distinct roots. E, we do exactly the same. 4x squared plus 4x. Looking at this, I've got a feeling that's going to be b squared minus 4ac. Yeah. So once you've got a, c here with 4 and 4, you're going to get a 0. So now you've got 2 real but equal roots instead of being distinct roots. So we need to put the number 2 because we've got a quadratics. So that's a fundamental. Whenever you're going to solve equations, it's the highest of your index will tell you how many roots you have when your equation is equal to 0. So that's why you need to put 2 equal real roots, or 2 real equal roots. For F, we get x squared plus 2x plus 1. That looks like, again, another 0. 2 equal real roots. Okay. So find the range of values of k for which the equation 2x squared plus 4x plus k. So this time, little c became k. And in order to have real roots, we remember that we had real roots when they're both equal, or when the 2 equal real roots, or 2 real roots distinct. So when the discriminant is positive and when the discriminant is equal to 0, you will fulfill this statement there. So you calculate b squared minus 4ac, you keep c as k here, and you end up with 16 minus 8k, And you can factorize 16 minus 8k because you've got your highest common factor here, 8. 8 times 2 minus k, which is 16 minus 8k. And when is this positive or equal to 0? When 2 minus k is positive and equal to 0, because 8 is already positive. So it's only when 2 minus k is positive or equal to 0. You can add plus k on each side. That means you get k or 2 is greater than k or k is less than 2. Okay, so that's how you would do that. And that's your answer there. K is less or equal to 2. So if I put k equal 1, you can quickly check yourself here that the discriminant is going to be positive. Whereas if I put k equal 2, it will give me 0. And if I put k equal 3, for example, I'll have no real roots. Okay, so we've done the same thing for the second one, but this time it was p for a. And we noticed that when p is greater than 1, this equation here would have no real roots. Okay. So in this case here, when we are asked to solve a quadratic equation and we are told that the answer is expected to be given with a certain number of decimal points, then you need to use what we call the quadratic formula. So quadratic formula is in your formula sheet. And that would mean you've got to calculate first, to make it easier for you, the discriminant, b squared minus 4ac. In this case here, I've got b equal to 13. So my next stage is to write my quadratic formula as negative b. So if b is 3 as a positive number, it becomes negative 3, plus and minus root 13, divided by 2a, with a is 1, so that's 2. You take your calculator, you do this calculation, and once you've done the calculation, you write first with a few decimal point after. So it would be 0.302 ... just meaning there are more decimals after the 2, and because you've been asked to round it to 1 decimal place, you look at the second decimal point. If it's less than 5, you don't change the 3. If it's 5 and over, the 3 just gets rounded up. The second one is the negative one, minus 3.302, rounded to minus 3.3 to 1 decimal point. And again, you will get full mark by answering the question. Okay. B, we do exactly the same. B squared minus 4ac, this time is 40. So if you were to be given something like this, solve the following, giving your answer to 1 decimal place. If you get discriminant negative, then ask yourself, you might have made a mistake somewhere. It's very, very unlikely that whoever is going to give you this question is going to make it an impossible answer.
My biggest problem is keying it in. If you forget a number or something in the calculator, that always causes a problem. But
the good thing is, once you know you've got, as long as you've got a positive number, then that's okay. Because even if I make a wee mistake here, let's say I put 28, but if this is 4 marks and I still get minus 4 plus and minus root 28 divided by 4 and give the answers to the 1 decimal place, I will still get marks for the rest. It's just that one, instead of 4 mark, I might get just 3 out of 4. But yeah, just do it a couple of times. So what I usually say to my student, do the calculation first, clear your calculator, do it a couple of times, and then once you've got the same answer a couple of times, then you feel more confident. Okay.
Yeah.
So 0.581, again, you need to round it properly to get the full mark there. C, b squared minus 4ac, again, so 40. So you can see it doesn't matter. You can get the same discriminant even for a different equation. Then you just write -8 plus and minus root 40. The answer should be different this time. I've got a negative number rounded and a negative number here for C. For D, again, I've got 41. So it's just a matter of plugging through 7 plus and minus root 41 divided by 2. 1 decimal place, 0.36.7. We've done E, so F. F this time, what I'm expecting to have here is root. So once you calculate root 120, you just calculate, you'll have basically two opposite number in sign. Okay, because of that 0 here. When b equals 0, your axis of symmetry will become x equals 0. Okay, so that's why we got 1.8, negative 1.8. So for G, same thing, b squared minus 4ac. So G is a classic one again, plus and minus root 17. You just give your answer to 1. But look at H. I'm telling you straight away, when I did H, I made a mistake straight away. What mistake do you think I've made here when I went to calculate my discriminant?
Need to rearrange the
Yeah,
formula.
so I forgot to rearrange it because what you'll find is it's not about the quantity of work that you do. It's probably better to do little but more often than to do too many because your brain just becomes into an automatic. So I was just looking at the first number and always assuming the first number was A, then B, then C. And if you've done it quite a few times, it's just repetitive here, then you'll miss this. So you need to rearrange it. That's probably why they've put it that way. And B is -2, A is -3, and C is 12. And then you do it properly and you get your answers. So rearranging it is important. The same for I here. You need to rearrange them with your B being 2 plus or minus root 28, and then you just give your answer. Okay, so just beware. Sometimes you might be given a quadratic not in the correct format or the way you've always seen it. So rearrange it first, do the work. So in this exercise here, we would ask which one will require the use of the quadratic formula. So that's not a typical type of question you may get because they told you here, do not solve them. So if it was a proper exam question, you will be asked to solve them. So like we said, we're just going to use discriminant will tell us if we need to use the quadratic formula or not. So the first one, we got 41 for the discriminant because you need to take root 41, and that's not just a normal number. So root 41 will have, so you need here your quadratic formula in order to give the answer. It's going to have some decimal place. Okay, so we will require the quadratic formula. For B, I get 16. 16 is 4 square. So you don't need here the quadratic formula because you get minus B plus or minus 4 divided by 2A. So you could have used for B a quick way of factorizing it and then be able to give your roots. So you don't need the quadratic formula for that one. Okay, so basically find two numbers. If you time them, you get 5. And if you add them, you get -6. 5 and 1 basic, or -5, -1. Okay, so x minus 5 times x minus 1. So you don't need quadratic formula for that one. For C, I get 52. So because root 52 is not a round number, you will need the quadratic formula. D, looking at this, I don't need, because I've factorized that. So I don't need the quadratic formula for this one. I know straight away what the roots are. It's 0 and 4. So E, we've done E before, yeah. As an example. F, I get 14. So root 14 is not a round number, so I need the quadratic formula. For G, you need to rearrange it. So you get 2x squared minus 4x minus 3. And you get 40. So root 40 require quadratic. H, you need to expand. And once you've expanded it, you get 4x squared minus 12x minus 2, 176. So I don't know root 176 on top of my head, so I will require the quadratic formula. And the last one, I get 24. I will require the quadratic formula. Okay, and the rest was just some example of past paper question that we went through some of them already. Okay, so today's lesson, have you got any question on parabola? I know we will do some revisions on them because there's quite a few things about sketching, about calculating the roots, about using discriminants. So there are quite a few things attached to quadratic formula.
No, I think I need personally